chapter 6 on the book. Okay, when we are talking about security from the first of this term, we talked about different aspects of security. We said that okay, security is science, security is an art. We talked about security policies, rules, and different areas related to this security, related to information security. From this chapter, from chapter 6 to chapter 8, we will talk about some security technology in the field of computer networking. Because in our view as a computer science, many computer engineers, security is using technology. Okay, and in the first step, we will talk about firewalls and VPNs as a basic, two basic security elements. Okay, what is firewall? Firewall is a special tools which it try to prevent some types of information, some types of packets, some packets moving between the inside of the network and outside of the network. Especially those traffics comes from outside, from internet toward inside of our networks. Okay. This firewall can be a separated computer, or it can be a software. It can be a software in a server, a software running on a router. I don't know, a separated network component. It can presented in different types of hardware or software phases. When we talk about firewalls, we can say that firewalls have 5 different categories from processing mode perspective. If I categorize firewalls from processing mode, we can divide them in 5 different categories: packet filtering, application gateways, circuit gateways, MAC layer firewalls, and hybrid firewalls. Okay, the first one is packet filtering. When we talk about packet filtering, a packet filter firewall checks the header of data packets, especially the IP, source and destination IP address, and its direction coming from inside to outside, or comes from outside to inside, and its protocol: TCP, UDP, ICMP, IGMP. I don't know. There are several protocols carries over IP packets. So especially we check these in firewall. We check these primary elements. Although we can check other parameters, other fields in packet header, in header of packets. Okay? But IP, source and destination IP addresses, direction, and different protocols, TCP, UDP, or something like that, are the main element that the firewall must check them. Okay, to do this, we have some rules in firewall. Those rules are designed to prohibit some packets entering from some special IP addresses, or from some special addresses. Okay. So we should focus on that rules to filter those special packets. But how we can do this? We have three different filtering mechanisms in packet filtering firewalls. The first one is static filtering, the second one is dynamic filtering, and the last one is stateful inspection. When we talk about static filtering, it means that we have some filtering rules. They are fixed in the firewall, and the firewall, based on those rules, decided, okay, what should I do? Should I drop this packet, or is it allowed to pass this way, this gateway? Okay, we call it static filtering. On the other hand, we have dynamic filtering. In dynamic filtering, the firewall can update or create new rules based on different events around itself. In static filtering, we have some predefined rules in the firewall, but in dynamic filtering, we have those static rules, those predefined rules, plus some new rules, some updated rules. We can update the rules, we can delete some rules, we can add some rules, okay? We can edit or update some rules. This is the difference between a dynamic filtering and static filtering. And also, the last option is stateful inspection. When we talk stateful inspection, it means that the firewall should keep track the connections between the internal elements and external elements in the network. We should keep track those connections. We should check the status of each connection, okay, in the network. This is the header of IP version 4. Header version, header length, type of service, identification, flags, fragmentation offset, TTL protocols here in the field of protocol. In this field, we can define the upper layer protocol, TCP or UDP, or even protocols which are in layer 3, for example, ICMP, IGMP, and something like that. And source IP address, destination IP address. You know, the most important ones in this fields, is protocol and IP addresses. However, we can talk about the rest of them. And in TCP and UDP, those TCP and UDP have their headers. You can see them here. Right now, I don't want to talk about these headers. You can find the details of these headers in the internet or in the books. But a firewall must understand these fields. The firewall would check these fields to decide about the packets. Should I drop this packet or should I allow this packet to pass? So the firewall sits here in the border of the network, and it will decide about the packets. It will restrict some data packets, it will block some data packets, and it passes some special data packets toward the network, inside of the network. So the firewall is a packet filtering mechanism. It can run on the border router. Okay, for example, here, look at this one here. In this figure, in this table, you can see some rules, some firewall rules. For example, the first rule says that if I have a packet from source IP address of 172.16. blah blah toward destination address of 10.10. blah blah anything, for any types of protocols, the firewall should block those traffics. Traffics comes from 172.16.x.y, for example, toward 10.10.x.x. Whole traffic, whole traffic from these sources toward these thresholds should be blocked. They should be blocked. But look at this one. If some traffic, some HTTP traffics comes from source IP address of 192.168.xy, okay, toward 10.10.10.25. This traffic is allowed. What does it mean? It means that 10.10.10.25 is a web server. Okay, so for web traffic, those traffics are allowed. They can pass the firewall. And look at this one here, 192.168.0.1 to 10.10.10.10. FTP service is allowed. What does it mean? It means that 10.10.10.10 is an FTP server. So I can connect from the gateway to this FTP server. Each rule has a specific meaning. We should understand those rules. The next type of firewalls is application gateway. What does it mean? Application gateway is a gateway installed on a dedicated computer for a specific type of applications. Mostly we call application gateway as a proxy server. Okay, proxy server is an application gateway firewall. What does it mean? It means that my traffic in some specific application should passes through this proxy server, and the firewall in that proxy server would check the traffic. Okay. So the proxy server or the application gateway should be placed in DMZ area of the network, or unsecured area in the network. Why? Because I want to send traffic over the proxy. So the best place is in DMZ, in the network. Because I don't know, I'm not sure about the traffic passes through this proxy. You know, how can I trust on that traffic? So it's better to put that server in the DMZ area of the network. And when we are using proxy server, it means that the traffic of some special and specific application would pass through this proxy server. So we can add extra security mechanism, security protection mechanism to our network, applying on the proxy server. Okay, and here this gateway is only used for a specific application. So the proxy server or application gateway stands among the most specific, the most effective types of firewall, because it works only on a special types of firewalls, types of traffics. The third gateway is circuit gateway. Circuit means establishing a circuit over the transport layer, layer 4. Okay, I'm starting to establish a circuit between the source and destination in layer 4, between the source process and the destination process in layer 4. And now I can check those circuits. I can check the traffic. I can look on the data of those connections. And this type of firewall is important for us because we can check the connection, the direct connection between two networks. Especially when those when the computers place in different networks. If they create a tunnel between those networks, I can check them using circuit gateways. I can authorize those traffics, those tunnels using this type of firewalls. The fourth one is MAC layer firewalls. It's a firewall on layer 2, MAC layer. So it can works on the MAC layer over the raw data in layer 2, over physical data in layer 2. For example, we can create an access control list to filter some specific MAC addresses. If traffic comes from some specific MAC address, it can, for example, block that traffic. Here you can see MAC layer firewalls works on layer 2, packet filtering works on layer 3, circuit gateways works on layer 4, and application gateways works on layer 5 to 7 in OSI 7-layer model. We can use a combination of these firewalls together. We call it hybrid firewall. For example, we can have a firewall, a packet filtering firewall with capabilities to work as a proxy service, working on layer 2, working on layer 4. Okay, it's a combined firewall or it's a hybrid firewall. Maybe sometimes we can use, instead of using a hybrid firewall, we can use some separated firewalls. For example, a packet filtering firewalls followed by a MAC layer firewalls followed by a circuit layer firewalls or something like that. We can use this type of firewalls tandemly. Okay, and also we can categorize the firewalls based on their structure. For example, some firewalls are standalone firewalls. Some of them are self-contained systems. Some of them are commercial-grade firewalls running on PCs, on general computers. Okay. Some firewalls are working for SOHO, small office, home office, or residential grade. Some of them are residential grade firewalls. Some of them are working on backbone. Some of them are working on DSL modems. You know, there are several types of firewalls. We can use them to do our jobs or work. For example, when we talk about residential grade firewall software, we install this type of softwares directly on the user systems. Here you can see some SOHO firewalls. Okay, but one main question. I want to buy and install a specific and I want to buy and install a firewall in my network. Okay. One main question is this: which type of firewall should I use in my network? Should I use in my residential implementation? There are some other questions too. For example, another one is that where the location of the firewall, where can I install a firewall? Why? Because I want to defend, I want to protect my network, my devices inside the network against the hackers. So where is the best place to implement, to install the firewall? You know, it depends on the situation. For example, someone decided to use a firewall software. It means that, for example, I'm installing a firewall in my computer, in my laptop, okay? It means that I allowed the hacker to enter to my computer. And then inside the computer, I will block the hacker. I will defend with that hacker, okay? But, for example, if I use a hardware firewall, this hardware is placed before my system. It means that my computer is behind that firewall. My information are safe. One more question. What about the architecture of firewall? Can I configure a firewall? The number of network connection architecture, can I configure it? When I'm talking about configuration of a firewall, this configuration depends on 3 different factors. The configuration of a firewall depends on 3 different factors. The first one, what is the objective of the network? Why I'm using the network? I'm manager of an organization. I need network. Why? Because of my business goal. So I should define the objectives of network. And according to that objectives, I can talk about the position and architecture of the firewall. The second one is the ability of my organization to develop and implement those architecture. I need some people who can work with the new firewall, with the new software, with the new hardware. I need those people. So the second one is the organization's ability to develop and implement different architectures. The third factor is budget, money. Everything has its own cost. We should pay that for that cost. We need budget. For those functionalities. Okay. The common architecture implemented in firewalls are packet filtering routers, screen host firewalls, dual home firewalls, and screen subnet firewalls. They are somewhat different. For example, when I'm talking about packet filtering routers, it means that I'm running a firewall inside the routers, especially the border routers in the network. Or when I'm talking about screen host firewalls, it means that I'm installing a software inside my computer. When we are talking about dual home firewalls, it means that I'm installing a hardware and firewall in a dual home device. A dual home device means that a computer which is connected to more than one network at the same time. At the same time, my device is connected to more than one network. We call it dual home firewall. And screen subnet firewalls means that I'm installing a firewall to screen a specific subnet inside my network. Okay. Let me talk about them more deeply. When we talk about packet filtering routers, it means that in the age of the network, the company uses a router. We need that router to connect to internet. Okay. So we can start the filtering mechanism over that router. That router, that firewall inside the router can be configured to protect the organization, to deny some types of traffics. But maybe one of the most drawbacks for packet filtering routers is that we should check them continuously. Lack of auditing and strong authentication inside the routers is the most drawbacks of packet filtering routers. Okay. When we talk about screen-host firewalls, it's a combination of packet filtering routers with separated dedicated firewalls with a separated application proxy server. Okay. So the router would pre-scan the packets entering into the network. It would pre-scan the packets and it will minimize the traffics over the internal proxy. Mostly separated hosts can be used in this case because maybe those separated hosts are good target for against external attacks. So I can screen those specific targets or systems in our network. So in this case, we call them bastion host. Okay. Look at this one here. This is the bastion host. So we need to filter, check traffic moving toward this bastion host. Okay, distribution. The dual home devices, I said that the dual home devices are connected to more than one network. For example, they connect to more than two different networks. And the most interesting aspects of dual home devices is that from one side, they are connected to, for example, network A, and from the other side, it would connect to another network. So in this case, we need FAT and we need NAT, network address translation. And in this case, we are using NAT, and also the firewall installed in a dual home host, it can check different items. Especially, it can sit and check intrusions comes from the external attackers. Okay, this slide here, this table shows the non-routable address ranges. We have three different address ranges. Those traffic traffics here coming from different source or destination. Each of them has a specific range, and I cannot use those traffics for routing over internet. You cannot use these addresses to route the packets over the internet. They are completely internal. Okay. Get this one here. This device is a dual home device. It's connected from one side to this router and from another side to these routers. You can, if you look on this figure, you can find different categories, configurations, and places for firewalls. In DMZ, we need screen subnet firewalls. This is the dominant architecture used today. In this architecture, we only screen some special subnets. In this case, we have two bus hosts. The first one is a router. At the edge of network, and the other one, the firewall is the firewall installed in different hosts. So when a connection, traffic comes from the outside network, comes from the unsecured, untrusted network, it's moving toward the external filtering,